So welcome to demonstration video 2 in our course B08 on data visualization, where we're looking at applying ggplot. So what we're briefly going to touch on here is looking at a simple question that you might encounter a few times, where you have a treatment group that are the cases and controls against which you want to compare. And you may have some protein of interest that has responded to the particular treatment, such as virus X here. So what we want to do is plot the actual data for the cases and the controls, not the summary data. So we see this all the time in awful slides and figures in papers like this. And these are awful dynamite plots or bar plots. And these are uninformative because they don't tell us about their underlying values. So what we want to do instead is use ggplot to tackle this. So let's switch to our studio where we can do that. So what we're going to do first of all is install ggplot. So know that the install packages command will do that. And then we activate the library, activate ggplot with the library command. There's a nice website here if you want more on the ggplot tutorial. This is just another version. We're going to use some of the tidyverse commands here. So we're going to install that package as well. You just need to do that once and then activate it every time you use an R session with a library command. So you can actually add a hash there, so you don't need to reinstall tidyverse. We're creating 10 samples per group. So just say n equals 10. And we're creating rnorm. We're using rnorm to create a function where we have 10 cases with values of 6 plus or minus 0.25 as the standard deviation. So you can see that these numbers are different every time we use this function, but they're kind of similar. These are our cases, and then we do the same for the controls. So if we look at the numerical data for the cases and the controls, they are different values, but they don't differ in terms of their summary information. So what we're going to do is just increase these, take the square of the original values to make the values more different, and we're just going to add into the cases 2 additional outliers. So now if we look at the cases and control, and you look at the summary data only, what you can see there for the cases, the median is 66, and controls is median for case controls around 66 and 63. You see the maximum is quite different for the cases. So what we're going to do next is create a factor repeating the case and controls 10 times. So we're going to repeat that over and over again. Those are our labels. You got 10 controls, 10 cases. Got 2 levels, cases and controls. So we look at those levels. You can see we've got those groups there, and the groups is something we're providing to the data frame as well, just to specify that we have the cases and controls, the values that we put in there. So put this together in the data frame dat, and we can view dat and look at the structure. And you see that there, we have the cases, and then we have the values are denoted by the groups. So you can see there we got 10 values for controls, 10 values for cases, and the 2 cases are values that are quite different from the rest because something went wrong. Then we use ggplot. So ggplot works by first taking input data. So data equals data is the input data, and we have x is within our data, and groups is within our data well. So x is equal to x is the x-axis, and y is equal to groups is the y-axis. We don't need to put in the x equals and y equals part, but sometimes it's good for our own memory. If you do this only, what we'll get is basically the background. So you can see that we've got divided this into a plot containing controls and cases, and then if you groups on the y-axis, that contains the values. But we've nothing plotted yet. So what we need to do is use a function like ggjitter to plot the data. If we do that, we're going to do that without the width function. You can see that the patterns are, the points are very wide there. So what we're doing is we're just going to scale down the width to be a more narrow distribution. So we plot them there. They're a bit more tighter in because they're not really overlapping yet. So that will work for us there. We can make them a bit wider if we want, like here. But there you can see visually the cases and controls. If we use the y, if we remove the y limb, it doesn't make too much difference really. So what we're going to do is add a box plot on top of that as well. So we do that. There you can see a box plot placed inside, and you see those 2 outliers in the cases groups are quite different. So you can see there there's no real difference between the cases and controls except for those two cases that are different. So what you can do to learn more about this is make your own data set, like we did above, use that code, use ggplot to plot it, do a box plot per group, then use jitter to spread the actual points. Of box plots, remember, contain a summary data as well. So that's why they can be useful, but they're not always useful. And what we can do again with the same data is try this other package called ggridges, which represents the same data but in a different way. So let's install that package. And again, we're adding in a different GM function on the back end of our plot. So our first part of our plot is the same. It's the same gray background. But you see there that we have a different arrangement because we know what function is coming next. So ggridges will plot the distributions for each of the groups on top of there. So we can see better based in cases that there's not quite a fully normal distribution. The tail there, there's a skew. And that can be informative. So what we can do is make more cases and controls. And we're just getting a longer data frame containing our cases to controls to, as well as our cases controls in the same way as before. We're calling that dot2. And then if we add dot2 onto here, we can see that we're able to plot the 4 groups like that. And we'd add more groups like this. So you can see these just ggridges can actually contribute more on our understanding of distributions that are of interest. So with your own data, from question 9, create your own ggridges plot. We can look at a particular question. So we have a question here on the number of virus particles per sample. We're given these values here, and we're asked to make a stem and leaf plot using a similar stem width and draw a box plot as well. So what we can do with these particles is assign them to a vector and use the stem function that draws a nice stem leaf plot like that. So you can see we've got a kind of unimodal distribution, single main peak. So let's create a box plot using the base of our functions. So we're cutting a green, we're limited the y-axis, and added labels on the side inside there. If we do this with ggplot, you'll note that we're reading in the particles as a data frame. So even though it's a vector, initially, that will not be tolerated by ggplot. We'll get an error. So if we did this without the data frame part, it'll give us an data frame. It will ask that data must be in a data frame. So if we do this with a data frame, what this will do is just plot the background for our plot. And then we're adding on GM jitter to spread the points out, adding a box plot as well, and then adding on X and Y labels here. So let's add these things in. And you see there, we have a spread of points with these particles and box plot represented there. So you can see the actual points and the box plot there, both. So let's look at another example, looking at compound concentrations for 10 samples there. So you can see these are smaller values, and we can add these to a vector where we're going to draw a stem and leaf plot again. So you can see there, they have a relatively defined distribution, a lot of values between 6 and 8. And we can draw a box plot in the same way we did before. You see there that we have less whiskers because a lot of the values are inside there in the middle. So the whiskers denote a fraction of our distance from our interquartile range, but here the interquartile range is quite narrow. And if we do a stem leaf plot in the same a ggplot in the same way with the data frame for concentration, you see here with the X, we've just left it empty because we don't have anything there. We only have one variable concentration. So we can add the jitter and box plot there to see the values more clearly. And that's a bit of a better plot than we had before. So we can see that's actually kind of 3 groups here for our data, really. Another example, looking at the RPKM values for some gene X, and we're looking at infected and uninfected cattle. We're looking at making a stem leaf plot again, get the 5-number summary, draw a box plot. So here we're comparing 2 different groups. So you can assign the infected and uninfected to 2 different vectors, like our example here. We get a stem leaf plot to summarize their distributions. So you see there for the infected and uninfected, we have comparable stem widths here. And we see that there's a somewhat different distribution between the infected and uninfected. It looks like the infected certainly have a higher median than the uninfected. That's visually clear. So let's look at these further. So we can draw them as well with by putting them into a data frame in ggplot. You see here what we're doing is we're repeating infected 20 times as a label for that group. And the same for uninfected. We have 30 samples there. So we're grouping them together. So we're concatenating this all together as one long vector. So you can see the labels there, 1 to 50, all placed. That's a group. And then the cases is simply the observed values that we had for these values. So we put that together in data frame called df. We can view df to check it. So we see there we have each of the groups infected and the number of values that we have for each of them. We can sort by the number of cases as well. You can see the cases, the values for the unaffected tend to be lower and the infected tend to be higher. Now we're going to create a semi-leaf plot in ggplot. Here we're plotting the groups as the x-axis. So you know that that's different. We now have another variable that we put in there that we have two different groups. So that means we have the y-axis, we still have the case values. So we plot that in our box plot. We can see we've got two different groups. If we remove that from the x value from here, it would just put them all as one box plot, which is not very useful. So that's why I add in the groups parameter to separate them out. We've also added the y-lim just to limit the y-axis so we can see them more clearly. So what you can do is try create a histogram with hist for a certain number of breaks for these two different groups. And also try these questions using the data as log scaled and exponentially scaled and see what difference does it make. So please see the next video where we're going to look at ggplot with large data sets.